Good morning, good afternoon, everybody, and welcome to another of our webinars on private LTE, private networking. Today, we're going to talk about, as the title says, how does private LTE evolve into 5G? This is the third webinar we've done in this series. The first one was building the network, building a private network. The second was on typical applications and services. This one is one of the most popular, actually. And probably the one we get the most questions on is how do I evolve from LTE into 5G on a private network? My name is Ian Gillett from IGR. I'll be acting as moderator today. And I'm going to run through a few logistics and then quickly introduce the panelists, and then we'll get into the agenda. For those of you who've been on the previous webinars, we've kind of done more of a conversational style in the past. With this one, given the subject matter, and it gets fairly involved, we decided to go back to a more traditional format. So each of the three guests today are going to speak for 8 minutes or so, then we'll open up for Q&A. Logistics, we are being recorded today. We will be taking questions today. If you have any questions, just use the questions tab on the GoToWebinar control panel there, and we'll either address them as we go through, or we'll leave plenty of time at the end. We will make the recording available. It'll be on the website after the event, and you can see the website there, privatelteforenterprise.com, and the other recordings are there as well. And we'll also make the slides available to anybody who's interested. So with that, I should quickly introduce our three guests today. Ken Hosak from Cradle Point. If you've been on the previous ones, he's been with us. I think it's number 3 now. From Google, Dr. Preston Marshall, who many of you will probably know. Preston's a pretty frequent speaker, very passionate on CBRS, etc. We'll hear from him today. And John Merchant from Cineverse. So I think, John, this is the second one you've been on as well. So
that's right.
And he hasn't got his Rockies cap on today. He's
still undefeated, though.
Okay, there we go. That's what he said last time as well. And he and Ken on the practice the other day were comparing their baseball caps. So okay, so in terms of the agenda, what we're going to talk about. Basically, I'm going to give a quick overview of private networks. This is a slide we've seen before. I'm going to take a little bit of different tack on it today. And then each of the panelists, Ken can go first from Cradle Point, then Preston from Google, and then John from Cineverse, really go through and answer the three questions. What does 5G give us? How do you migrate from LTE up to 5G on a private network? If you're planning to put in 5G, what do you need to think about today? And what sort of timing can we look at? And each of them will address those questions in different levels of detail. I will tell you, the conversation before we got started today, it was getting pretty technical. So we've got some deep engineering depth here today. So if you do have questions, we can get in some detail on the capabilities here and what to expect from LTE and of course from 5G. Finally, the resource websites there, I will put these up at the end as well, but obviously Cradle Point, Google and Cineverse. Google, of course, we all know, but the Google/Get/Spectrum Database/SAS takes you actually to all the stuff we're talking about today. Okay. So with that, and as I said again, if you have questions, use the questions tab on the GoToWebinar control panel. Now, this is the slide I've shown before. This is kind of how we view the world in the next 5 to 10 years. Everything on here is 5G. You can see we've got 5G macro cells on either end. And then we've got these islands of the yellow, if you like, of more dense coverage and capacity in different areas, covering the home, stadium, manufacturing plants, etc. So this is kind of a view of the world eventually. I think a lot of people look at this and say, oh, well, I need new spectrum for this, or this is all going to be millimeter wave. And the answer is no, it's not. Our view is, and I think we'll get into this a little bit today as well, is that just as everything migrated from 3G to 4G, so everything in 4G is going to migrate eventually up to 5G. It's just a matter of the evolution along the standards path. Again, from our point of view, 3G to 4G was more of a forklift upgrade. There was changes to the air interface. With 5G, it's more incremental. There's been some tweaks, but we're not fundamentally changing the heart of the air interface. And in fact, the first versions of 5G we see, 5G NR, are actually using the core from LTE. And I think today we'll talk about some of the capabilities you get as we get into releases 16 and 17 when we get into the new 5G core. But all of these things, again, there's a lot of capabilities in 5G. We'll talk today about the different capabilities you get over LTE, the different performance levels. Some things on here, you really need 5G. Other things you can do pretty well with 4G, actually, with LTE. And of course, everybody jumps straight to the autonomous vehicles and all those good things, but there's a lot of other very useful, very applicable applications and services that could be supported. So with that kind of setting the stage, oh, and of course, I've got the private networking piece of this, is, within these, we can have private networks using CBRS with LTE, CBRS with 5G. Coming down the pipe. You could also have a private network using millimeter wave, especially manufacturing is talking about that as well. Obviously, you'd need the involvement of an operator there. In countries that don't have CBRS, you're going to need to go talk to an operator, and operators, certainly in Europe, have opened up spectrum to do that. So with that, I'm going to hand over to Ken from Cradlepoint and let him walk through who Cradlepoint is, then get into that 5G discussion. Ken.
Thanks, Ian. Much appreciated. So Cradlepoint is, according to a couple of research firms, the worldwide leader in solutions that help enterprises use LTE as an enterprise WAN, as an enterprise basically internet connection. And so because of this, I mean, we're used in all sorts of fixed locations, such as branch offices, retail stores, convenience stores, a lot of mobile locations. These are vehicles, vessels, etc. And then a lot of things that would be classified as kind of machine to machine, so kiosks, digital signage, smart cities. And the reason that's relevant for today's discussion is through our customers, we come across hundreds, if not thousands, of use cases that really benefit from using wireless as a WAN. And as we talk about, a lot of our use cases are LTE for using public networks. But also increasingly during the last webinars, which we're not going to go through, we talked about a lot of the use cases for using LTE on private networks. And today we're going to put more of a flavor on the 5G part. And the 5G is a big key initiative for us. I think we have some press releases. We're launching our 5G solutions actually in Australia next month. And we've got our whole lineup. So our engineers are actively working on that. And if you go to the next slide, I think it's important to understand, and I got my ham radio license when I was 13, and we've come a long way since Morse code in terms of how much data you can put into spectrum. But I think it's important to understand the difference between 5G as a technology versus CBRS, which is basically a standard for a given spectrum. So 5G, you can run in a variety of frequencies. You can run it in low band, mid band, high band, some people call sub-6 or millimeter wave. But CBRS is specifically that 3.5 gigahertz that Preston has been working on with a lot of other folks to work with the government, the military, and the government to be able to do this spectrum sharing. In general, the higher the frequency, the more bandwidth you can carry per hertz. In general, the higher the frequency, the smaller the distance that travels. And in general, the 3.5 gigahertz is a very, very attractive spectrum for 5G because it has a good balance between the amount of data that it can carry there versus as well as the distance. So if you go to the next slide, a lot of the focus that you see in the CBRS discussions is on the infrastructure. It's really about the small cells. They're called CBSDs, et cetera. As well as the EPC, kind of the SaaS infrastructure to be able to support this. But as we're launching our 5G solutions, since we're an endpoint, by the way, we are the devices that attach to the cellular network, whether it's 4G, whether it's public LTE, whether it's public 5G or private 5G. And since this whole series is all about enterprise use of these private networks, one of the things that we're learning is that you need that enterprise management. It's a lot more than just the RF. And so you can see the devices that we have down there in the lower right. Because of the fact that we're supporting enterprises for being able to use 5G, we also need to be able to support that in an enterprise class from a management standpoint, from a reliability standpoint, the monitoring standpoint, and frankly, the ability to support system integrators and managed service providers with things like installer apps and the tools that they need to manage it. So if you go to the next slide, we believe that if the WAN can be wireless, it will be. And we saw this just like Wi-Fi took over the LAN. We believe that wireless is going to take over significant market share of the WAN, the wide area network, the internet. And so we've gone through, again, in previous, a lot of the use cases for 5G. And in general, if you take CBRS out, you look at 5G in general, we believe that 5G is going to be a technology that really goes after a lot of fixed wireless applications. And it's going to be the carriers, obviously, that are rolling this out as managed services, but we see the impact that it's going to have on enterprises, the ones that want to set up their own private networks. But if you look at the difference, and a lot of the questions that came in before the webinar that we looked at, a lot of people were asking, how do I upgrade from 4G to 5G, et cetera? It really depends on the hardware that you implement. So the products that we just released over the last two months are specifically designed to be able to upgrade to sub-6 5G. So there are modules that we're developing, and everyone who's developing around kind of the Qualcomm 55, X55 chipset, we're all going through kind of our scheduled challenges of when we actually get that up. But we found that we had to really beef up the platforms to be able to handle 5G line speeds. And so kind of the platforms that we just launched this quarter are really focused on giving you the horsepower from the standpoint to be able to run things like IPS or IDS at line speed, to be able to run containers, to have all the horsepower to be able to handle 5G. And then we have the ability to upgrade those to 5G. The nice thing about the use cases, if you focus on the use cases, is a vast majority of the use cases can be addressed by LTE that we're seeing. And that's great news, because today's solutions, it's already there. It's available, it's commercial. If you want to deploy a private LTE network, you can do that today, and everything's in place. The use cases that specifically require 5G, however, from a CBRS perspective, since it's the same spectrum, the same channel sizes, we're really not seeing a ton of use cases that require. There are certain specific ones where they need that lower latency, maybe a little bit of the increase in bandwidth that you can get with 5G, but really a vast majority of them are adequately covered with LTE, and it works great. So anyway, I just wanted to point that out. We're obviously big proponents of 5G, but in the 10 megahertz channel spacing that you get, it's not necessarily a huge difference at that frequency. And that's why I was pointing out at the beginning, it's important to understand at which frequency you're actually running the 5G, because that's where you get the big bandwidth differences. So I'll turn it over to back to you, Ian. I appreciate it.
Okay. Great, thanks, Ian. So actually, you talked about some of the questions. We did get a lot of questions in from people as they registered. One of those ones, as you said, is, will I be able to upgrade? So those new devices you've got, you said, with 5G capabilities today, if I'm using those with LTE today, and then I deploy 5G in my network later on as a private network, do I have to do anything to the devices, or am I always set?
Well, we have two types of devices. The ones that we're launching next month are 5G devices that come with 5G integrated into them. Outdoor unit, indoor, because we are supporting millimeter wave, and that doesn't penetrate buildings. So we have the units that will essentially convert the millimeter wave or the sub-6 to Ethernet and then bring that in. But then we also have other enterprise platforms like branch routers or mobile routers that are designed for sub-6, and those will have the ability to upgrade it. So if you deployed that today using private LTE, you'll be able to upgrade that to private 5G.
Okay, great. Okay, Preston, I'll hand over to you. Same set of questions. 5G capabilities, evolution, timing, and I do like your first title here. So.
Well, thanks very much, Ian. Thanks for inviting me. It's my pleasure to be here today. The standard for this kind of presentation is introduce your company, because people may not have heard of it, but I don't really get that opportunity coming from Google. But it's probably important to talk a little bit about why Google is so active in CBRS and wireless here. I should also say that if you look for my opinion as dispassionate advice, it isn't. I'm a strong believer in CBRS. This has been about a 8-year project for me to go from the original White House work up to seeing it launch the beginning of this year. And Google and I put a lot of work into this band, and it's because we really think CBRS does something that's unique. That is, it's not just more bandwidth. It gives an opportunity for new mobile fixed bandwidth suppliers. And when we talk about innovation, it's not just innovation in a better waveform. It's innovation in new business models, other than just you pay for a monthly subscription before or after the month. We're seeing new kinds of opportunities opening up, because this is the first time people have had access to both a large quantity of spectrum and a really mature supply chain that is constantly evolving because of the demand for the tier ones. So this is a really unique opportunity. We want to see whoever you are provide bandwidth to users, because in most cases your users are our users, your customers are our customers. It doesn't make any difference to us whose equipment you use. We don't even care whose SaaS you use, because getting bandwidth out there serves the entire world. Next slide, please. So LTE to 5G evolution. The good news is that if you think about this process, you're not the first one, and you're likely not the largest one, because operators throughout the world have faced the same challenge, salvaging their investment in LTE, moving on, not having disruption. So there's 3 steps you can think of. There's the off-the-shelf LTE, there's a non-standalone 5G, which is the LTE core plus the 5G new radios, better radio performance, potentially better antennas. And then there's the sort of 5G holy grail, which is standalone, where you bring in the 5G core and the 5G new radios. Architecturally, they're similar, but there are some uniqueness to this, and you have to think before you say, I want to go to 5G. 5G is not big bang. It doesn't suddenly happen. You can mix and match these depending on what you want to do for your networks. So if you start out with LTE, you have the advantage that you're coming into a fully mature ecosystem. It's supported in every new handset. Non-standalone mode improves the radios, has options for massive antenna performance. And then when you go standalone, you're bringing in a whole new concept for networking. So you may or may not need a new networking concept. You actually might not care that much for the performance of the new radios. But the process in this is similar to all of them. And you should really think that when you do it may drive what you do as much as what you need. Next slide, please. So this is the one sort of technical slide in here. If you think a bit about what's going, you can think about 3 components that you'll be thinking about when you do 5G. You've got a network, you've got a radio technology, the NR radio just referred to, and you have antennas. We already see 5G antenna technology coming out in some of the early CBRS deployments, particularly in the fixed wireless space, where we're seeing the massive MIMO antennas from 5G. When you go to non-standalone mode, you're keeping the same network concept together. You're getting a better radio, and you're getting the opportunity to add in these very, very more effective antennas. Now, if you're serving inside a enterprise space and you're putting up omnidirectional antennas, you don't really get much out of the antennas, and the performance from the NR radio is better, but not disruptive and not game-changing. If on the other hand, you're doing fixed wireless, where you're serving customers that are a kilometer or two away, then we're seeing people get 3 or 4 times better performance just from the antennas as they start to deploy in CBRS. The last level of 5G is when you go to standalone mode. This introduces a lot of the features that have been used to argue for why 5G was needed. Network slicing. If you're building a network that has multiple stakeholders, it allows you to allocate spectrum to you. From the point of view of Google, we're a computing company. Mobile edge computing is introduced in the standalone 5G, where you can distribute the computing and the telecommunications control assets so you can get very high performance like you use for online gaming. And this is where the low latency and the high quality of service. But you don't have to make the leap all at once, and you can kind of pick and choose among these. Next, please. So when you think about this, it complements Wi-Fi. There's a lot of people want to put 5G up against Wi-Fi, which is better. They're really different. LTE and 5G provides you the ability to manage QoS. They give you entry control, get significantly larger cover range because you can manage the bandwidth much tighter, and of course the security and control. Where they become different, where we depart from the Wi-Fi experience, is that it's a more complex network. It's going to depend on a cloud service to operate it, the Spectrum Access System. We're one of the several providers of those services. And in particular, you've got to think about planning the network. It's much less tolerant of poor planning than Wi-Fi. In Wi-Fi, you go out, you hang it up, and it finds a way to work. This was built for deployments to be engineered. CBRS doesn't have mandatory coexistence. You have to plan around the other nodes. CBRS, either your own nodes or the adjoining nodes. The performance is impacted by your signal levels. It doesn't go over the same dynamic range as Wi-Fi, so you have to really understand, is there a tree in my path? Is there a building? How much multipath am I going to get in the environment? So for that reason, one of the products we put together was a network planner. So if you look at the detail when you use Google Maps or Google Earth, all that detail is what you need to plan these networks. So in addition to offering a Spectrum Access service, which is more or less a commodity right now in terms of the capability, we've also taken Google Earth and made it available to people to plan the networks. So if you look at a lot of the propagation models, they kind of model the world the way it was about 360 million years ago. They don't even account for trees. They use just terrain. Here's an opportunity to get down and understand, is there a building in the way? How tall is that tree? Is that tree a deciduous or a fir tree that will leaf out in the middle of winter? And secondly, when we built our systems, or we looked at CBRS, we wanted to make sure that there were the same reliability behind the Spectrum Access System that people would expect to see in some of the very, very high performance cloud products. And so therefore, we made sure that at least one SaaS was implemented essentially on the same infrastructure as what Google Search runs. And if Google Search goes down for 2 seconds, you read about it in Wired magazine, no time at all. This is something. So when you look about thinking about going to 5G, think about yourself having to take on some new responsibilities. You get a lot for it, but you take on these new responsibilities. You should think about, how do you source those? Who can provide not only the SaaS, but the ability to understand what a network looks in the environment where you're deploying. Next. So there's a natural path. 5G is not a one-step thing. You grow into it. It's not monolithic. You can make use of 3 different technologies, mix and match them, but you have to take on more responsibilities. Google's been pushing this from the very beginning. For a little while, we were the only major company supporting CBRS because we really wanted to see the emergence of the new use cases. No one held private LTE or private 5G sessions before CBRS came along. It's a brand new opportunity to come to you. But when you do it, think about what you need to leverage it for your enterprise, not just to meet the minimum demands, but to help you do the planning, understand the signals, understand the interference from your own networks and from other networks. What buildings are in the way? what tree is in the way, what foliage is in the way. All of these issues really become important. And make sure that you're on an infrastructure that's as reliable as your radios. These people build radios with 6 nines. Make sure the cloud service that supports it has that same one. I will, it's kind of hard to imagine, but Google runs 40,000 searches a second. It can handle SaaS. Thanks.
Great, thanks, Preston. So actually, we had a question come in specifically for you, and I'll address it right now. What's happening with the use of CBRS spectrum outside the US? And I assume they're talking about having the lightly licensed approach we have here with CBRS. We've got a quick 30 seconds update.
Yeah, I wish more. CBRS is uniquely US allocation. We're the only country that's done it. We're the only country that was willing to make this leap and trust users to manage spectrum in this way. Just like we were the only country to establish unlicensed led to Wi-Fi. So just like the world followed the US lead in Wi-Fi, I am sure the world's going to follow the lead in some ways for what we've done in CBRS. CBRS was convenient spectrum in the US because it was occupied by the military, but with very low density of use. The band may be different in other countries. We've seen Germany, for example, move to a very localized licensing that has a similar effect of enabling private networks to be deployed. And there's a lot of interest in the UK for similar regimes. But step one is to have the rest of the world get CBRS envy. And I think so far we're in a good path to that.
Right. Yeah, I'm just imagining all the Google application developers sitting there listening to you going, hey, that's a good idea. Let's do Google Earth prehistoric so we can see what it used to look like 360 million years ago. So, okay, John, you've been sitting there very patiently. Same questions, 5G capabilities, timing, applications, rollout, and how we evolve there.
You bet, you bet. So let me just start off with an overview with Cineverse. Unlike Preston, my company doesn't have quite the brand awareness that his does. So we are involved in essentially interconnecting mobile networks, and we do a number of things around those interconnections, focused around 3 key areas. One is the physical network and all the control that comes along with that. So enabling a device to roam from an AT&T environment to a Vodafone environment as an example. We also manage a lot of the messaging interworkings, SMS, MMS, RCS type messages. And finally, we're a transaction engine. We actually clear and settle about 4 billion transactions every day around enabling these different business models. And so we're applying those assets into the enterprise space as well. So let's kind of walk through just a few key attributes. One is we're connected to over 750 mobile operators around the world. We're connected via those operators to nearly 7 billion users. So we like to call ourselves the most connected company in the world. We've got that same infrastructure has been repurposed into enterprise market, and we have developed what we call secure global access, which enables enterprises to also get interconnected via the same 5 nines MPLS network. We're also supporting Internet of Things at a fairly large scale today, with thousands of relationships, millions of devices that are passing data over our networks every day. The clearing and settlement, I mean, I can't emphasize this enough. As we start getting into really multi-party network relationships, service relationships, the ability to authenticate participation in that service chain, track usage in that service chain, and then clear and settle the financials based upon that usage is really important to foster innovation and creativity around new services and features. And then finally, we're leading the way in making sure that these networks, as 5G emerges, remain interconnected and actually leverage a lot of the advantage that 5G core, 5G radio are bringing to bear. All right. To the next one. Now let's just talk about kind of the technology speaking for myself, I like to geek out on this a lot. I've been tracking 5G for probably, I don't know, 5-6 years. I was with Ericsson before Cineverse and was did a lot of work back in those days too. IMT 2020 really kind of pushed a lot of the feature requirements around 5G networks 3GPP ended up ultimately adopting them. And there are, roughly a dozen or so different features that were defined here. And I'm going to focus on just a few of them. Ultimately, these features were built or defined in order to support 3 high-level use cases: enhanced mobile broadband, which is really what we're achieving now with the 5G non-standalone deployments, and then critical machine type communication, also known as ultra reliable low latency comm, URLLC is the acronym. And then finally, massive machine type communication. And massive is kind of like what we're achieving now on LTE, but even more so, right? And what this really points back to is a couple of key feature growth areas. One is in just the throughput through a cell tower and a network of anywhere from 200 to 300 today to well over a gig. And you achieve that through a number of different technologies. I think Preston had referred to several of them. The other is the latency and dropping the 4G latency maybe 300 milliseconds. At times it can be a little bit less, but down to 3 milliseconds. There's even talk of going sub 1 millisecond. Anybody who's been around the communication industry for long knows that, those are just amazing latency performance milestones. And then finally, it's around device density. The 5G network really needs to be able to support many, many more devices on a per kilometer basis than existing 4G networks. Anywhere from essentially up to 1 million devices per kilometer. A couple of other really key issues around 5G. One is going to be around availability, trying to get a more reliable, more available network. Another is on mobility, being able to track devices and maintain communication for devices moving at 300-400 kilometers per hour. Sorry. So a lot of really stringent performance metrics around 5G. We go to the next one. Now, so what does this mean for private LTE networks? We think about private LTE evolving to 5G in a couple of different phases. The first is going to be to adopt the new radio, 5G new radio. This gets you into that 5G non-standalone architecture. Some of the benefits, and I won't belabor these points, but higher performance user equipment. We have more efficient use of spectrum. MIMO becomes more capable in 5G. There's also something that's been emerging in some of the early deployments around 5G in the public arena, which is dual connectivity. You can have a device that actually maintains connectivity to both the need node B, which is the control point for the LTE RAN, and the G node B, the control point for the 5G RAN. So that couple different advantages there. Going down to the bottom, what we see is the next step is 5G standalone architecture. And as everybody says, this is it. This is the sweet spot, right? And here what we're seeing is the ability to really deploy a much more customizable network. We do have CUPS, which is control plane, user plane separation, conceptually in LTE networks today, but it really becomes much more robust in a 5G network. And one of the things that allows you to do is implement network slices that we really can't potentially even conceive of today. And think about an LTE, a private LTE network, or turning into a private 5G network. If you're running multiple mission critical use cases within that facility, you can use network slicing to be able to guarantee the right performance characteristics for the right use case, and do that all on the same network. You can also scale up and scale down certain capabilities within the network and certain functions and microservices accordingly, so that you won't run out of capacity to operate those use cases. So that's really a big improvement. And then finally, there's also the ability to create multi-party service models. What's interesting, if you talk to big operators, as they deploy 5G, some of them are no longer looking at a single source core environment. So in the old days, they might go to Ericsson and have Ericsson build out the entire EPC of all packet core. Now they may cherry pick, from Samsung for one function, to Nokia for another, to Oracle for a third, really choosing best in breed function capability to build out that 5G core network. Really great. And then the last area we're looking at is millimeter spectrum improvements. So particularly in building deployments, a lot of factories and industries are really looking to that millimeter spectrum to deliver that really high bandwidth to deliver on some of the low latency requirements, and also take it out of crowded frequency ranges. Now, CBRS certainly doesn't cover millimeter today. That's specifically around the citizens band range, but we could see some sharing of millimeter spectrum moving forward that allows enterprises to take advantage of that spectrum in their own building. Big disadvantage there, environmental interference, right? We were joking about this a lot prior to the call, but Charlie Brown's Christmas tree can get in the way of a secure communication, or even any communication. Okay, in full disclosure, that was Preston's joke. I apologize, but thank you for letting me borrow it, even if it was implicit. All right, so let's move on to the next one. So this is the busy slide, and I'm not going to go over every major point, but there are a couple, I think, good pieces of information on it. One is just looking at the big box in the bottom there. I think it's a very interesting display of that end-to-end network connectivity requirement, and you ought to take a look at it at your leisure and just see if it can explain some of the interactions we see. But let's talk a little bit about what some of the key issues that we've run into around 5G upgradability. First and foremost is the radio. And most private LTE deployments right now are going on lower end RAN access points. In order to achieve a software upgrade capability, you're going to have to invest in some more expensive RANs that could potentially stress your business cases, at least early on. Now, there are certainly some trade-offs around that. You do have to pay more, but at the end of the day, you don't have to deploy new access points to get advantage of the 5G new radio. There are a few vendors out there who are doing just that, but they generally do tend to be, again, more expensive. Now, on the other hand, if you want to maintain support for private LTE, the devices in that same facility, you're really going to have to operate both an LTE RAN and a 5G RAN. So, there's also some justification for really building, an overlay network of 5G as you think about making that migration. So that's one area. Another is going to be the core. As you deploy a 5G core, you have to make sure that you can maintain support for the devices on your network that are still LTE, which means you essentially need to invest in what's called a dual mode core, or a 5G core with 4G interworking. That's going to be important, again, to be able to support your legacy devices. And it's also going to be important in the next issue, which is interconnectivity. So I'll talk about that first. Even if you have a private 5G network in your building, if that device goes off net, there is no guarantee that that device will be covered by a 5G standalone network. It may be covered by a 5G non-standalone network, which again is controlled by an evolved packet core, or it may be controlled or connected to an LTE network, which again is controlled by that evolved packet core. So you have to have the ability to communicate with other networks via 4G. Now, with that also going back into the interconnectivity piece, 5G core has different standards and protocols for communicating with other 5G core networks. The diameter signaling system, which is what controls operator-to-operator communication today for 4G, actually goes away in a 5G core, and it is replaced by new technology that's based on HTTP2. So you need to make sure that you've got that capability to be able to roam from one network to another. You also have to invest in an SEPP, which is a security edge protection proxy. That is the function that ensures end-to-end security from one network to another. That's also brand new, so you need to make sure that you've got that capability in place as well. And then finally, you need to be able to handle, different generational interconnectivity, going from a 4G network back to your own 5G network and so on. So those are some of the key areas that we think about as you consider a growth pattern or growth path to 5G. And that's it for me.
Great, thank you. Okay, so we've had a lot of questions. I think we'll set a record actually. I'll just summarize this very quickly and dive straight into the question. So what this all means, obviously we talked about performance of 5G compared to LTE, we talked about speeds, talked about lower latency, talked about more devices per kilometer squared. Not monolithic, it's different applications need different network attributes, and not all applications are going to need 5G. As our carrier networks evolve from 4G to 5G, so private networks will evolve as well along the same path. And so the private networks are going to evolve as well, and we could get additional frequency bands supported as well. So for example, John mentioned millimeter wave, for example. And of course, the vendor ecosystem here is migrating along those same paths as well. So there's obviously support for the enterprise as we move. So I'm going to open up for questions. And actually, what I'm going to do, I've got a couple, one for each of you, then we'll open up some bigger discussions. If we don't get to all the questions today, I'll get answers to everybody on some of these. There's some good questions here. So Ken, there's a specific product question here for you. How many 20 megahertz wide LTE carrier ag channels, I guess, can Cradlepoint's product support in band 48 to support higher speeds? Very specific.
No, it's a good question, and you know, a lot of it, we use a lot of the module providers, and so we work with them. It's a question I can't answer because if I did, I'd be telling you more than I know. I do know, just to be clear, but I do know that you know that there's difference on carrier ag on the downlink than the uplink, and so obviously on the downlink there's more opportunity. But I think we're really on the uplink is kind of where people are really interested in looking at some of this, because a lot of the use cases we're seeing are video surveillance cameras that need to come up, and so as a result, there's a lot of work going in the CBRS Alliance to really figure out how to optimize that uplink and what to do there. So
okay,
that may be one we'll have to answer
yeah.
offline.
Okay, Preston, you mentioned the network planner, the Google Earth. Are there plans to expand network planner into indoor propagation, modeling, and prediction?
I'm the wrong person to speak to where they're taking the product. I think there are some products out there that do that better. I think our general view is you can measure that if you're indoors. Real data is always better. It's hard to go and measure the downtown New York, but if you're renting space, go there. We're actually maybe publishing the methodology we use for our data collection so other people can use them in calibrating our models. So, you know, if you're doing indoors, get into space and measure it, it's going to be better than anything we can predict. Although I think there's some fairly good rules of thumb. And if you look at the standard deviation of indoor estimates, it's typically 6 dB-ish, whereas our measurements show outdoors, the standard model was always wrong by at least 40 dB. So we've attacked the bigger problem, which is 10,000 times wrong. How many times people can sell a product that's wrong by a factor of 10,000? But so that's the low-hanging fruit, and that's what we're after now.
Okay, great. And John, can Cineverse allow connection to a private LTE network that's already covered for roaming? So I guess if there's a private network there, can you provide roaming to the macro network?
Yes, so we've got a couple of different technologies, and this is currently in the 4G space, but we see it also going into the 5G space. We can allow either another private network device or even a public network device to access a private network in accordance with any agreements that are put together up front. And conversely, if you do not wish to have these devices on your network, we can exclude them specifically as well. So it really, there is a great deal of flexibility in how we do it. One uses the traditional roaming patterns, so we just basically recognize the private network operator as essentially their own little MNO. Another is an interesting technology that's been around for a while, but is now gaining some steam, which is called MOCN, or multi-operator core network. And that allows the RAN to actually broadcast on a carrier's PLMN ID, which is their network ID. In that case, you take your AT&T or your T-Mobile phone into a building, it connects to it just as if it were a radio on that home network, which is, I think, a really interesting approach. And it allows for the segregation of data. The private stuff still stays private. The public stuff goes straight back to the operator network. So pretty interesting approaches.
Okay, and I'm glad you mentioned MOCN, because that was 2 other questions you just got rid of as well. Okay, so I'll read this question, and we touched on speed quite a bit today, but I think this is probably the bigger discussion here. What is the maximum speed I can get with a 4G LTE? So far, the maximum I've got is 80/50, so 80 megs down, 50 up. That's pretty good. Is the speed going to improve when infrastructure changes to 5G, or do I have to change to a 5G device? Let's take that one first.
Well, I think
by 5G device, you mean, well, I mean, the handset's different, and likely the radio, if that's the question is.
Yeah.
Coming
at it. I'm sorry, go ahead, Ken.
Yeah, just quickly, I think this was the conversation we were having right before we started the webinar. Is if you have, basically you're looking at the exact same spectrum, and you're looking at what are the speeds I can get with 4G versus what we get with 5G. And I think some of the discussion we were having around that were the better antennas, or the more improved antennas. And Preston was talking about that as well. But John, to you.
Yeah, one of the earlier deployment scenarios for 5G was in Korea, SKT, KT, and LGU+. So they've been running it for a while, and we're getting some real world data back from 4G versus 5G performance. And I think they were looking at LTEs maxing out at about 100 meg, and they're seeing about a 3 to 5x improvement in the 5G speeds. Now, one caveat to that we all have to keep in mind is that it's people like you and me who are buying these 5G handsets, and we tend to pound the heck out of the network. So some of that could actually reflect some of the usage patterns rather than the device capabilities. But we are seeing those kinds of multiples on performance.
Okay, all right, good. Preston, this is probably one for you. A little bit of clarification here, and I'll just read it and I think paraphrase a little. Does 5G, either NSA, SA mode, or both, need a SAS like in CBRS to operate?
Yes. As far as I'm concerned, you couldn't have a baby without a SAS. However, the FCC only requires it for CBRS. So the SAS is technology neutral. We did a lot of work, so it's not a Wi-Fi SAS, it's not a 4G SAS, it's not a 5G SAS. So it is pretty much common to whatever you deploy in the band, and there's people deploying Wi-Fi derivatives using SASs and all. So yes, you're stuck with it in 5G.
Okay, so if you put 5G into CBRS, in CBRS you're always going to need the SAS.
Yep.
If you're using millimeter wave or something, you're not
free spectrum comes with a cost, and you're trading billions of dollars of capital for a monthly charge for using a SAS.
Right. I think your quote about having a baby requires a SAS may go down and be used elsewhere. I don't know. We'll see.
Yeah, well, they already stole my Charlie Brown, so.
Okay, a question here. Again, we've touched on this one, and Ken, I'll let you take this first, and maybe John, and then Preston, pack it up. Wi-Fi 6 and 5G, do they coexist? Does one replace the other? What's the relationship here? And we get this question a lot. I think 5G maybe has been positioned a little bit as the Wi-Fi replacement, and Wi-Fi 6 came along. So, Ken, how do you view it from your point of view?
Yeah, well, I always look at, kind of our diagram. There's a private LTE umbrella that covers licensed spectrum, shared spectrum, and unlicensed spectrum. So you can go to a carrier and license spectrum from them if you're in the mine in the middle of Nevada, or maybe you hire the operator to set up the network for you. Similarly, you can run LTE, and there's some work going on to run it in unlicensed spectrum as well, like in the 5 gigahertz range. But the problem is that there's also baby monitors in there. There's HDMI transmitters. It's a crowded spectrum. And so fundamentally, you're only going to be able to be as good as the spectrum that you're running on top of. And so CBRS the benefit is it's not unlicensed. It's actually, you basically have access to it. So you can have general access to it or priority access, but you kind of have to play by the rules in there, and you have the SAS. So specifically around Wi-Fi 6, what we're seeing is private LTE really addresses a lot of issues, certain applications that really struggled with earlier versions of Wi-Fi. And that's why we, specifically we're seeing where people want to create a wide area LAN. And I think Wi-Fi 6 does a good job of addressing some of the specific issues with contention interference. I think Wi-Fi 6 is going to be groundbreaking technology. But again, the sweet spot for private LTE and 5G is you're running it in spectrum that isn't crowded, you're not competing with other uses.
Okay, John?
For me, I think it's always going to be a discussion more around which you use for which use cases and which scenarios. I don't think it's really an either or at that high aggregate level. The main benefit of the LTE and then of course 5G is that you have a controlled interface between the device and the radio and ultimately the core. And that allows you to be, I think, you get some better performance out of that device to radio connectivity, specifically around security and around distance, around device densities, around power consumption. And so whenever you have use cases that really rely on that, that's going to be the beneficial one. But in terms of passing gigabits of data from a radio to a specific device, I don't think anything really beats Wi-Fi.
Okay.
Yeah, I'll grab that one for a second. It's a dangerous one because we make more money selling you a Wi-Fi access point than we do selling you a SaaS subscription. But you should think about that it's a trade space. In this case, not between necessarily two technical things. The carrier technology, be it 4G or 5G, requires that you really understand and plan your network. Wi-Fi has incredible tools to just work out of the box. You take no responsibility. If you want to manage your network tightly and plan signal levels and plan interference, because it's not tolerant to it, then you get a lot out of the carrier grade technologies. If you just want to throw it wherever it happens to have an AC outlet, then you have a lot of advantages in going in Wi-Fi. The difference being the listen before talk protocols versus the managed power in LTE. Like I wrote a chapter in a book just on this subject because it's sort of, it becomes sort of tribal loyalty sometimes between Wi-Fi and LTE. But there is a very engineered arrivable region where you will get much better performance with a centrally managed type of program like within LTE. And then if you don't manage it well, Wi-Fi will be far superior.
Great. So last question here, we've got a few minutes left. We've got probably more technical on this session than we have in some of the previous ones, and that's fine. There's been a lot to talk about. We've still got quite a few questions, but I want to end with this one is, we've talked about SAS, EPC, we've talked about MOCN, MOCN, we've talked about latency, all these, I'll call them more technical terms, and some pretty complicated diagrams. So the question is this so complex that an enterprise cannot deploy a private network, let's say with CBRS? It's a little bit of a challenge. I think I know the answer. So let's go Ken, Preston, John. Ken, from your perspective, how easy is this to deploy today for an enterprise, let's say the average enterprise who wants to put a private network in?
Yeah, no, it's a question that I understand very well because here at my house, I installed and ran a private LTE network all of last year. So I went to the FCC, I got an experimental license, they call it an SDA, and I installed an access point in my house. I connected my Cradlepoint router. Everything in my house goes through the Cradlepoint router. All of my Echoes or Google Assistants, all of my TiVos, all of my laptops, Windows upgrades to a Cradlepoint router. And then it was kind of mid-hauled through private LTE, and then it would go into my cable modem. And in this case, I used a cloud-based EPC, so I simplified it. But for me, it was actually very, very easy. There are other enterprises where the use cases are a little bit more complicated. Obviously, a lot of people are going to have more higher power small cells. They're going to want on-prem EPCs. And those get a little bit more complicated, but all you got to do is know how to install a VM into a PC for the EPC, and it's not that complicated.
Okay, Preston?
Yeah, I had the same, I'm not going to talk about this thing until I've hacked it attitude. And so I did it at my office. And, it is like the difference between running your Windows server and running, say, Gmail. The transition, we're not just talking about a different radio, but we're transitioning to managing it with the cloud resources, as just mentioned. So I think now, if you were setting this up and you had to fill a rack bay with mobility managers, EPC, all that GORP, yeah, run the other way. But there's been a lot of work done to scale this and put this in the cloud. So you plug the RJ45 in the wall, and one connection goes off to a SaaS, and one connection goes to the cloud provider for the box. And we've seen, at least particularly the people specializing in enterprise, having this pretty much integrated in the same way that an enterprise Wi-Fi management system would be. So I think there's a little more to learn about, but I think once you get past the learning, the actual operation of these networks pretty much has the exact same block diagram as a typical enterprise Wi-Fi deployment.
Okay, good. John, you get the last word.
All right. So I think, our focus at Cineverse has really been on kind of the larger enterprise deployments. And we think about private LTE as not really the value driver for that enterprise, but really more the value enabler. At the end of the day, it's really about what use cases you're doing and why you're focusing on those use cases, what your objectives are. And private LTE is just one way of facilitating that. So when you think about that broad ecosystem, there's just a lot of things that go into it. And I guess our view is, let the scale of some of these cloud or EPC providers like ourselves help you out. Let somebody who really knows how to design and deploy a RAN help you out. And then if you want to participate in the broader mobile ecosystem, you're really going to have some operational maturity to be able to do that, because operators aren't going to let any mom and pop private network connect to theirs. They're going to have some standards of operational support, security, et cetera.
Great. Well, gentlemen, I want to thank you today. For those who've been listening, we have been recording today's session. We'll send you details on how to access the recording. We'll also make the slides available. But from Cradlepoint, Ken, from Google, Preston, and from Cineverse, John, thanks very much. We've had some good feedback on this one. It's a good session. Thank you.
Thanks.
Thank you.